Today we will be discussing the carbonation laboratory. In this lab, cleaning in place procedures, the process of carbonating a beverage, and various hurdle technologies were applied. Carbon dioxide is added to a mixture under pressure in the absence of oxygen to begin the process of carbonation. Carbonated beverages are widely enjoyed by consumers all over the world. Before the beverage was made, the tank was sanitized using clean-in-place procedures. A cleaning mixture of water and powdered brewery wash was pumped into the tank through a spray ball. Following that, the tank was rinsed twice with water to remove any leftover cleaning solution that may be left behind. The tank was then tested with a hygienia to test for ATP, which would indicate the presence of living microorganisms. The reading came out as 0, indicating a passing score, and meaning the tank was clean and ready to be used. Several hurdle technologies were applied throughout this lab. Citric acid was added to acidify the mixture to a desired pH of 3, and at a low pH, pathogens cannot grow and spores will not germinate. By pressurizing the tank to 10.3 psig with carbon dioxide and also removing oxygen, another hurdle was achieved. Low oxygen inhibits the growth of many spoilage organisms. Pressure can be an additional microbial inhibitor, and the addition of sugar also lowered the water activity slightly, although probably not to an extent that would totally inhibit microorganisms. Additionally, the clean-in-place steps taken in the beginning of the lab could be considered a hurdle technology as well, as they completely sterilized the tank before the production of our Gator Bubbly began. Various equations were used throughout this lab and are described as follows. First, Henry's law can be used to find the concentration of a gas dissolved within a liquid at equilibrium. It is described where P is the partial pressure of the gas, Hc is Henry's constant for the gas and liquid at a specific temperature, and C is the concentration of gas dissolved into the liquid. To correct Hc for temperature, the following equation was used, where Hct is the Henry's constant at the new temperature, and Hct reference is the Henry's constant at a reference temperature. T and T reference are both in Kelvin. Additionally, the amount of citric acid necessary for the mixture was found using the equation below, where C is the concentration of acid in the beverage. To find the amount of CO2 present in the headspace, the following equation was used. And finally, to find the water activity of the beverage, this following equation was used. To finally begin creating our Gator Bubbly drink, the desired parameters had to be set and a formula had to be made. A Brix of 5 and a pH of 3 were selected. The amount of sugar and citric acid to add in our beverage was calculated based on 100 liters of water. The calculation of Brix is shown here. Next, the amount of citric acid necessary for the mixture was found using the equation below, where C is the concentration of acid in the beverage. The carbonation level we chose for the beverage was 2.3 volumes of carbon dioxide per volume of soda, or 4.6 grams per liter. The CO2 was bubbled into the solution through a carbonation stone to a pressure of 10.3 psig in the tank to reach the desired carbonation level. The temperature would then be lowered to 5 degrees Celsius, and the pressure needed to have 4.6 grams per liter was calculated using Henry's law, as seen below. Because the CO2 in solution would reach an equilibrium with the gas in the air, the amount of CO2 in the headspace was calculated. At 5 degrees Celsius and 10.3 psig, there would be 423 grams of CO2 in the headspace of the tank, as calculated below. Finally, we calculated the water activity of the beverage. A high water activity was to be expected, as our beverage is primarily water. In conclusion, the objective of this lab was to explore the production of a carbonated beverage, including all the clean-in-place procedures, designing and calculating a formulation for the beverage, using these calculations to then find Henry's constant, and then evaluating the final product. Various characteristics, including Brix, pH, carbonation level, final headspace, and sugar content, can all be controlled and manipulated to meet consumers' demands for carbonated beverages of all kinds.